In this video, I'd like to continue talking about finding the area of rectangles. And let's start this by looking at a specific example problem, and then we'll try to come up with a formula that will work for any possible rectangle where you have any possible length and any possible width. So remember, the strategy is that we're trying to figure out how many unit squares we can fit inside of our bigger rectangle. So remember, a unit square, in this case we're dealing with meters, so we would have a 1 meter by 1 meter little box, or a 1 meter by 1 meter square. And the area of this, of a unit square, would just be 1 square meter. So we're trying to figure out how many of these can fit inside of our bigger rectangle. And remember, the general strategy is to split up each of these side lengths here into 1 meter lengths. So we want to split this length here into 5 different pieces. And 5 is a little bit difficult, but we can roughly guess where they should go. So that's 2, 3, and 4, and 5. And they're not going to be perfect since we're drawing this by hand, but you can get a rough idea. And of course, each of these lengths is now 1 meter, and we have 5 of them, so the total length of the side adds up to 5. And we'll do the same thing for our width here, this 3 meters. We're going to split this into 3 equal pieces where each length is now 1 meter. So this is 1, and so is this. So each of these boxes now is 1 square meter since it has length 1 and width 1. So the area of this box, like I mentioned, is just 1 square meter. And we could just add these up. There are 5 up here, 5 more here, and 5 more here. So really we're just adding 5 of these square meters for each of these rows. And in total, we have 15 square meters. Or in other words, we have columns of 3. So we have one column of 3, 2, 3, 4, and 5. So there are 5 of those columns of 3 square meters. Since you have 1, 2, 3, you add those together, and this total column has an area of 3 square meters. So the general idea is that we're doing repeated addition. And when you see repeated addition, you want to think that you're just multiplying. So we're either doing 3 times 5 or 5 times 3. But in both cases, we are going to get 15. And really, we should be a little bit more careful with the units here. We're taking 3 meters and we're multiplying it by 5 meters. 3 times 5 we know is 15. And we have meters times meters, which we're just going to rewrite as meters squared. So something multiplied by itself, we can write as that thing squared. So if we want to be a little bit more general about this, we can come up with a formula. So let me just make a little bit of room. And we can create another rectangle here. This one will just be a more general rectangle where we're dealing with what we can call the length and what we can call the width. So to find the area of this, basically we would follow the same process. We would split this up into many different sides. And actually, let me use letters for this. Let's call this L. And let me be more clear, that's an L and not a 1, so I'll use a cursive L. And we can call the width W. So we can break this up into as many pieces as we need, where each of these pieces has length 1. And we can go all the way to L for our total number of pieces there. And since we don't know what L is, it's very general. We're going to leave it generally here. And we'll do the same thing with our width. So the main idea is that maybe this is our first box, our second box. This is length 2 now from the end. And we go all the way to length L from the end. If this is 2, this is 3, and so on, if we were just marking off each step of 1 in length. And we would do the same thing with our width. We would break that up into W pieces. So let me change colors for the width. So that would be our first box, our second box, And again, each of these lengths are going to be length 1, and we'll go all the way to length W, where each of these 1, 2, 3, and so on goes all the way up to W. And again, each of these has length 1. So we're just marking off each increase in 1. So we could, in theory, add up all these boxes by just thinking it through. So think about this first row of boxes here. We would have, where each of these boxes is 1 square unit, we would have L of them in this first row. And we want to think that we just have W rows. So just like we did here, where we had 5 of them in the first row and we had 3 rows, we would add 5 3 times. So in this case, we would add L W times. And adding L W times is the same thing as just multiplying L by W. So our formula for the area of a rectangle is just the length multiplied by the width. And this formula can be used for any type of rectangle that we have, though it is important to remember where this formula comes from. So you never want to just memorize something in math. You want to be able to understand it. And if you ever need to understand where this formula comes, just create some rectangle for yourself with some actual numbers for your length and your width, and then split it up into small boxes, where each of those boxes has an area of 1 square unit. But one of the main reasons a formula can be useful is that sometimes these numbers get really big, and we don't want to be drawing all of these little tiny boxes into some huge shape. So as an example, let's say that we have a box. Let me draw that really quickly. Some rectangle or square, where maybe one of the side lengths is 23 meters and the other side length is 46 meters. And to find the area of this, we could just use our formula, where in this case, our length is 23 and our width is 46. So the total area of this rectangle is just our length, 23 meters, multiplied by our width, which is 46 meters. And if you actually calculate this, you get 1,058 square meters. So remember, your units for all of these are going to be square units when you're talking about how much flat space that a surface takes up.